Hello, everyone, and welcome back. My name is Corey, and I guess you're my rubber duck for the evening. And this is the series of episodes where we are creating a programming language from scratch using C++. Vim is our editor. We're in a terminal window, going really old school on this, except for modernish C++. And of course, using some basic, I don't mean basic as in simple, but basic as in fundamental tools such as Flex, Bison, Google Test, and ICU. And we have been working on our optimizations, and the optimization we've been focusing on is the ability to, in our opcodes, well, we've been specifying kind of the opcode, and I'm still wondering, is there a better way of doing this? I'm thinking about it. But anyway, in our opcodes to be able to specify, should we reach into the stack for an operand of some sort, or should we take something from the top of the stack? And by default, everything was just top of the stack. Why? Because that got everything working, and I don't know how many opcodes we had, but that's what we needed for our machine. And now we're focusing on, well, if we can keep from requiring putting one on top of the stack, then we should be able to reduce the number of operations. Why? Because we no longer have to copy something out and then access it, but rather just point to it directly. Yeah, that's the goal. So what have we done? We started off with our function opcode, and then we went into all of our binary operands, binary operators. We didn't do and or. We might consider that, but the next one I want to focus on, I think, are our cast operators. So what we're going to do, let's go to the code and, well, do our normal things. Make clean, make test watch. And while that's doing that, I always want to demonstrate where we are. If I say get status, the only thing that's there is a call grind from before we did any changes, and that's just so I have something to compare with. We'll do that later. And now, let's see, get log. The last commit was the end of episode 91, so you saw that in the previous episode. And now we're going to, do I have my Vim? I don't think I've got my last Vim command. Wait. Ooh, yes. Let's see, opcode.hpp and .cpp, program analyze, program dump bytecode, program execute, and I had AST node binary. I may keep that rather than binary. Let's is there a cast? AST node cast, yeah. And we'll use AST node unary as our reference. So let's look at that. In fact, that's the unary. This is the cast. And we've got our way of casting to 4 different things: integer, float, boolean, and string. And let's see what else. So we compile whatever the expression is, and then we add a cast to it. Well, that's kind of what we should do. But what, you know what? Let's just go to the very first one. So now, look for the word cast. There we go. There, now we've got all these versions, and we're going to say cast integer, cast, and we're going to do the same thing, an S version and an I version. And so the S will be the top of the stack, and the I will be an index. And we're always doing S first, followed by the I. And rather than going the whole Papa Val, whatever, we're going to say just typecast to int. So how many is that? 1, 2, 3, 4, 5. If I say 10x, so I need to do 11. 11x, okay. I know that could be done faster if you had a multi-cursor editor. I don't, so. All right, so now we've got all of these, and on the right-hand side, we're going to get some errors because we no longer have our cast boolean and all that other stuff. We're just going to continue on. Now we're going to, let's find cast. S I S I S I S and I. All right. Now for, where are we? This is the analyze. What I want to see is on the, yeah, we just did it that way. All right, that's fine. So I think it'd be faster if I say y7 and then just paste it here. Yeah. And then y7, paste it there. And now we'll say S I S I S I S I, and now for the dump program check of 1, we're going to need both of those, and that's going to be when there is an I. All right. All right. So that's all of those done. Let's see, which one are we on? We're in the dump bytecode. So we're going to look up cast. And can we use this dump unary? Where is that? Oh no, dump no, dump binary I. Go up to the very top. What did I use for the negative? Dump binary. That was dump binary I, but dump binary is just print out the opcode increased by 1. Binary I is that. So that's what we need. We need dump binary and dump binary I. Okay, so there's dump binary. All right, and now we need the dump binary I. We can do that by doing this, dump binary I. Now, we've got other problems we've got to fix. If I look for a colon space, there we go. S I S I S I. No, wait, I got off. S I float S float I cast Boolean I think I just pasted it in the wrong place. I S I, and now let's get these fixed. This is dump binary. This should be I. All right. Last but not least, we're going to look for plus PC. That's fine. No, that is not good enough. Look for out. All right. That all looks right. This is in the execute. Okay. So what did we do for negative? We did unary op S, unary op I, and I think for the cast, so that's what it looks like for the cast op S is going to be a stat check. Don't need that. but we'll keep that. Nope, don't need that there. All right, and now cast stop I. Just replace it all with that, and we're just calling it. Oh, it's still being called operand. You know, that's fine. Operand. Except this is... Oh, index operand. Okay, that's fine. So I think cast stop S and cast stop I will work just fine. So we're going to do a cast op something, and I'll fill that out in a moment. All right, now we need to make 9 there. All right. S I S I S I S I. All right, and then last but not least, these right here. S I S I. Hit one too many things there. S I S I. All right. So I think I've got all of my execution stuff. Now, how do we compile this? We're going to steal from the unary. We're going to do this here. There we go. So instead of unary op, we're going to call this cast op. So operand is being called the same thing, and in fact, you know what? I think all these are, that doesn't need to be changed at all. case. There we go. And now integer, float, float, nope, Boolean, Boolean, and string, string. Yeah, and now if I look for the word add, that's basically unary op should be cast stop, right? Is that what I called it at the top? Cast stop. Yep. Oh, AST node identifier. I need to include that. And I'm going to go ahead and add that to the make file. All right, and now what are we complaining about? Oh, it's not called operand in this one. What's it called? I don't know. Expression. See if this works. All tests are passing. Yes, that is good. All right. There. See what our diff is. Added our dependency. We've got our new opcodes. Got our identifier. That's fine. That's fine. Our descriptions. for analyzing. To dump. I don't like the name dump binary. I might change all of those. We'll just say. Let's see. Then cast stop. What's our log? How are we phrasing this? Add SI opcodes. Okay. Cast integer, cast float, cast boolean, and cast what was the last one? String. Okay. So, of that, I know it says 131 insertions, but 50 deletions. So, we doubled the amount of code, basically, but we also doubled the number of opcodes. Okay. But we use macros, and it's smarter now. All right. All right. So if we did it for that, I don't have the WSL view docs HTML index. There we go. And what I want to see is the opcodes. Here's our opcode list. Easier to see here. We could do the same thing with the jump false and jump trues. And it would be basically the same. We would have a jump false S versus a jump false I. What about the jump false pop? No, that's if it's on the, yeah, that would, we don't need a version of that. That's going to use the stack. Should it be named jump F pop S? I don't think so. Not for the moment. But jump F, there should be an SI, and a jump T, there should be an SI. Yeah. I think that makes sense. All right, so go back to our Vim cnode. Who all's going to use that? You know, forget that. Let's do cd source so that we can get grep -in jmp f. So that's in the ooh, this is going to get, because this is going to take more work. I know you're probably thinking, well, Corey, what are you doing here? I'm just kind of staring at it. Well, my thought is we could add the jump F and the jump T commands, and we just won't be implementing them at the moment. So let's do this. Whoops. There we go. So the jump F, we're going to copy that, and we're going to now have an S and an I. Yeah. And we'll do the same thing for jump T. All right. Jump F, jump T, S, T, S, T, this is analyze, jump F, an S, and an I. The I is going to need to read two values, so we're going to need that to be a PC plus 3. And then the jump T is actually jump TS and jump TI. Okay. Dump bytecode. So we've got this dump binary. Oh, so we've only got a jump binary I. So the jump F, you're going to need we're on line 92. Okay, go back up to the top. Dump Yeah, dump binary. That's what it is. There. Binary I. Right? Yes. And then this is also a dump binary I. Okay. Now we need to, this is going to be underscore S. This is going to be underscore I, and now this is II. There's two values to print, that's why. Jump T is now S I. Okay. This is the execute. So we're loading this and it's condition. Okay, but the PC is different depending on what. So are we able to use any of our macros on this? No, they all are executing. Okay. Nope, I didn't mean jump, I meant okay, let's figure this one out first. So the S doesn't change. It's all the same. This could be simplified to PC is equal to condition double equals false. That should work. Now, jump FI, on the other hand, how do we do this? Line 318 is where we're coming back to. And all that we need to do is jump any of this, I, execute program check 1, index is that, stack check index, operand is equal to that, and there. All right. I don't think our our compilation is going to work at the moment, but we'll see. Yeah, we're going to have to jump F. Okay. This is AST node unary. Okay. So edit source AST node binary 138. Oh, okay. So here's where we can because if yeah is the only difference in these two lines the true versus the false. Fine. Compile program. I think it is. It's just checking for true versus false. All right, so let's clean this up a little bit, shall we? Yeah, this is ugly. But it's worth it, I think. Well, for just to get this compiling, let's come back to this, okay? Right now we know that these can be jumpf underscore s because that is the default behavior, and jump t underscore s. Program execute. What? I thought I fixed those. Oh. Yeah, I only did the jump F. I did not do the jump T. So let's grab that there. True. There. All right. And Now for the I, okay. So that's all taken care of. Continue with the compilation. Oops. Oh, it's in optimize. Okay. Ooh, this is going to need some more work. Okay, that's fine. So I think let's do this. Let's do jump opcodes S, jump opcodes I. Okay. And okay. Still not gonna like it. So this is going to be jump opcodes S. And now we need one for jump opcodes I. Why? Because if it's in the I, now we've got to get to, well, where is the target, right? Oh, what did I do? For the... I think I messed up. In the execute. So on the I, the index is the very next one. And where we need to jump to needs to be PC plus 2. And the PC will be incremented by 3 if it's not. Right? And that means we need execute program check of 2. Yeah, we need to make sure that there's 2 more values there. This arrow bytecode, PC plus 1. I know I'm thinking too hard about this, but bear with me. Yeah, we'll do the index first, followed by that. Okay, so now the jump if false I, same thing. Execute program 2, index is PC plus 1, else PC plus 2, and this is plus 3. Yes, because it's got one more. Now the optimize, now we're back to this, and we're saying jump opcodes I. The target is offset plus 1. Oh. We may have another problem, but we'll get there. Do I need to separate these? Oh, the target is not bytecode plus 1. It is indeed bytecode plus 2. Yes. That means all of these. Yeah. Plus 2. There's another one on line 190. Okay. So this will be jump opcodes underscore S, and this will be underscore I. What are we doing here? This one does need to be plus 2. Okay. That should work. 250. One more. That's why, by the way, I did rename them underscore S and underscore I so that the old names wouldn't work. Bytecode offset plus 2. All right, and we're always in between 4 and 5 milliseconds there. But that at least gives us a jump F, S, and I, even though we're not using the I yet. T, jump TI. All right, all of that looks good. Opcodes, okay. I couldn't remember what format I was using. All right. So, yeah, we're back down to 4 milliseconds there. What's the problem? I'm glad you asked. Come on, over here. There we go. Let's just look at our classes, our program class. What I wanted to show you is that when we are compiling, look, there's a break stack and a continue stack. These are things that we need to go in and fill in. But, you know, this may not be a problem. You see, what I was going to say well, yeah, set jump target. Set the target address of a jump opcode. Let's look at that. Look at this. This is a to-do. All right. What was our other file that we were just in? Where I had the jump instructions. Wait. Sorry, I just realized, I think the other day, didn't I figure out that Shift K? Nope. Or is it Control K? No. Okay, I don't know. Never mind. Forget that. If I just say git show, this will tell me where it was. Where did I have those nice two lists? Jump opcodes, S and I. Yep. And that's in program-optimize. Okay, fine. There we go. No, really, those shouldn't be there. They should be at the top. All right, so we can say this. We can say if jump opcodes dot count, jump opcodes underscore s dot count there. Then do something. And this should be a +2. And it's an I. There we go. There. That's what I was trying to do. Okay. Now what calls set jump target? Pop the break stack, pop the continue stack. Oh, okay. That's just, okay, so that's safer. Are those the only two? So they're never going to really need the I. That's just, other things may. Ooh, but I could use this. So validate instruction. ref before trying to set the target. Okay. I guess I needed to add it first, don't I? Now rerun the commit. There we go. That didn't answer the question of where's the problem now. Right now, nothing is producing this. Yeah, that's an easy way of saying it. Nothing is producing a jump, an I instruction. So if I edit the source of AST node binary, this one, so we had 4 variants, and that's kind of, you know, I'm going to yank out 7 lines there. I'm just gonna, what to do about the left-hand side. So there's a left-hand side index, right-hand side index. And, you know, we could do both of these. And we'll replace that with right-hand side, and then the right-hand side index is that. All right. Now we kind of have the same issue as above. Where we've got these 4 situations. And in fact, what's the only difference between the and the or? It's just the jump true versus jump false. And is that right? So the and, if it's false, doesn't need to evaluate the second part. It's false. Okay. If the If the right-hand side is true, doesn't need to evaluate it, and it just returns true. If it's not true, if it's false, then it pops it and will evaluate the other side, and it's whichever one that is. That is accurate. So the only difference is jump true versus jump false. Okay. So let's not do these here. Rather, let's we're still going to have 4 options, but it's going to be the jump false, jump true. But is it? No. Well, wait. It's not the same. Because it doesn't matter what the second one is. The second one always has to be left on the stack. Yeah. That's the truth. Doesn't matter what the second one is. The second one always must be left on the stack. So all that we care about is the first one. And are we looking at a jump if false or jump if true? That's what it is. Okay. So up here, we're going to copy this. Okay. So yank 40. We'll say logical op, and then we need those 2 versions. That's fine. I don't need to evaluate the right-hand side. I just need to say, is the left-hand side greater than 0? If it is, then we're about to do some work. And for that, we'll just go down to the bottom and grab these, go back up, plop them into place, and then refactor. So I don't have to do the left-hand side recompile, but I do if it's the else. There. That's the else. All right, and I'll worry about the rest of that in a moment. And I'm going to call this condition jump is wherever the next one is. And then we add the bytecode of the op underscore s. Yes. So, okay. So whatever the op is, if the left-hand side index is greater than 0, yeah. Add the bytecode, and then add the placeholder. And when we call set jump target, because it's an S. Oh no, wait. This should not have been an S. This should have been an I. There. Should have been an I. And set jump target will set the correct place. Okay. But we're using left-hand side index because index is the left-hand side is an identifier. Great. And then we compile the right-hand side. Easy enough. Yeah, that's all that has to happen. Uh-oh. Can I not put a comment inside of a macro? I don't think I can. Otherwise, evaluate the left-hand side. The condition false jump, that it needs to be OP underscore S. What I'm realizing here is the ending is the exact same. So we can just do that. The wind is really blowing outside. Op S and op I. Okay. If this works, that'll be cool. And this is using you know what? Forget trying to replace it. JMPF. Which one is first? S? JMPFI. And this is JMP T. Last thing I want to check is I left a return at the end of both of these. I don't think that there should be. Get my indentation fixed. All right, so we've got condition jump, and now we need to do this condition false jump, and not auto anymore, not auto. There we go. See if this works. All right. All tests are passing. That's always a good thing. Let's edit the source program execute. Why? Because I want to see just if these are being used. I haven't done a lot with ands and ors in my test cases, so. Ones and threes. So I'm not using the twos and fours, which are the I versions. Okay. So I've got true and true, true and false. So that was testing assignment. Because I didn't have variables at the time. Well, I kind of did. That was testing short circuit evaluation. Let's do this. Let's do there. We will say that's not right. What does that look like? R quote open. Yeah. There we go. And now we're going to say A is equal to 1. B is equal to 2. A and B. And it should be true. Let's see if this gets the optimization. It should. Yeah, we got the optimization there. The number 2 showed up, and the OR worked. Well, should have. Let's try it again where A is equal to 0. I got a 2. Oh, because it just returns B. That's not right. Well, it returns it and then... No, this... that kind of makes sense. Because I could say... How do I do my cast? Just an as. Is it as Boolean? I don't remember. Stack is empty. All right. Why is the stack empty? First of all, I want to make sure as bool. So it is giving 2 and 2. My question is, why is the as bool not returning? Wait, that's wrong. A is false, so it should instantly return false. Okay, so I've messed up somewhere. So I don't think the as bool should matter. It should just be false. Let's double check this. Oh, the test. P1 dump bytecode. Just have it tell us what it's thinking. So we've got a null and a null. That's going to be our A and our B. Integer 0, poke that in, integer, which is 0, poke that into A. And then pop, because that's our A is equal to 0. Integer 2, poke that into 1, pop. Jump if false. So if 0, that's A. If that is false, jump to 18, which doesn't exist. So that's where it would be ending. And let's see what it's executing. This is going to be messy. That's okay, we can do it. Alright, so what I'm doing is I'm telling it to output the opcodes, the order of the opcodes. As it's executing them. Of course, we're getting them for everything, but only one of them has a fail. And that should be this here. 0, 1, 2, 4, 6, 7, 9. That is right, isn't it? 0, 1, 2, 4, 6, 7, 9, 11, 12. 2? Wait. Jump FT. I think that should have been jump FI. Where would that be? Yeah. Should have been an I. That's a minor thing. I did not mean to close those. Oops. Go back up. What I don't get is why it's saying 2. unary, binary, find the jumps. There we go. And this is jump fi. Oh, because I do a cout too. Ha! Okay. So it executes 12 and exits. Oh! So here's the issue. Before, we were putting the value on the stack and leaving it on the stack. Now we're not putting it on the stack, and so what we're leaving on the stack is what's in B. That's why. So the jump if false should leave a false on the stack. And it doesn't need to pop. So if it's... Okay, so let's fix a few things here. This is going to be in the source AST node binary. For the logical. Okay, sorry. Down at the bottom. Do we do the pop? No. We only do it if we had to compile the left-hand side. So there. Okay. So the pop is only there if we compile. Left-hand side. Got it. Now what? So I think these two are going to have to go there. And I'm going to have to do something special with the left-hand side. Excuse me, when it's an index. First of all, okay, so where is the condition going to? Oh, that's going to be the jump. Based on the index here, and I don't know where yet. The problem is then I compile the right-hand side. So what I think needs to happen is the right-hand side really needs to jump past wherever this is. Okay, so I need to put it on top of the stack is what I'm saying. So this is going to be because I don't know where yet. And that means I need to save this one's location as auto RHS leapfrog is equal to the size. Okay, added an unconditional jump there. Dot peak where LHS index. All right, so now what this is going to do is after I compile the right-hand side, it says, okay, just tell me where I'm about to jump past some stuff. So RHS leapfrog is just where that jump instruction is. And then I set the jump target of the conditional jump to right here, where I just peek that index location. And then I say, okay, now the leapfrog goes past the peak. So either way, that should work. Now what happens if it's a normal thing? It'll just do its normal job, has a pop. Cannot convert an opcode to an integer integer t, even though that's its type. That really annoys me. What does it look like? 72. Evidently it wants me to add a semicolon. Who'd have thunk it? This is C++. This is C++, not JavaScript. Hey, we passed everything. 13 milliseconds. We're printing out a lot of stuff. But if we go up here, we will see the the overall thing, integer 2, poke that into B, pop it. Now, if I is false, go to 19. 19 will say reload that value, because that's what should be on the stack. Yeah. But if it's not true, then just peek 1 and then jump to 21, which would be past this. Why 21 instead of 20? Because often there's a pop after this peak. So, all right. Anything else? Yes. for the moment, commenting out these couts. And I think we're going to try the same thing with an or. Or it should be true. Oh, and I don't need to dump all these bytecodes. Well, that's okay, I can. Run this one more time, get some separation in here. All right, so this first one, well, it's this one. A is equal to 0, B is equal to 2. But either way, A, B, integer 0 is going into A, pop. Integer 2 is going into B, that's fine, pop. Jump if it's true, if A is true, which it is not, to 19, which that would reload A, that's fine. Otherwise, go here, peek B, jump to 21. That's fine. Makes sense that these are working correctly. All right, and the only thing I was doing this for is so now we see we've got 1s, 2s, 3s, and 4s, and all of our tests are still passing. So let's get rid of those couts, shall we? So in the binary op, we refactored that a little. Oh yeah, we moved the lines. Logical op, did that. Fixed our ands and ors. In the opcode.cpp, we fixed a typo. We'll do that separate. Opcode.cpp. And then we just added a few tests. Okay. For now what? Opcode.cpp. Typo in printable name for JMP-TI and JMP-FI. And on the right hand side, I'm going to go ahead and do our standard make clean and then make tests. Just one more last recompile before, because we're about to do our final stuff. When available. All right. It's all good. Let our computer work a little bit, right? Earn its living. It's the winter right now. Well, it's not that cold outside, but I was going to say it helps heat the house, you know, when you do stuff like this. For episode, anybody know? I don't remember. 92. Episode 92. While that's doing that, I want to, on the left-hand side, say build apps Tang-s feed in fib.tang. Oh, and do time. Look at these beautiful numbers. Improving all the time. That's 1/10 of a second faster than when we started. I'm happy. We're doing a lot of work in that 1/10 of a second, but it's valid. It's valid. Valid amount of work. All right, so I'm thinking. Give me a sec. Oh yeah. What do we have to do? Tag it as episode.092 -m episode.092. And the last thing that we do is count the lines of code, see where we are, and 12,400 lines. Okay. With 3,700 lines of comments. All right. I wish there were a way to put comments inside the macro. Maybe I probably could just without the double slash. I might do that. Anyway, but for now, we are in a good place. We've done a good amount of work. We've I want to see this. Nope, not that. Include opcode. There. 97 lines. So there's, you know, a few of these that are blank lines, but not a lot. So we've got over 90 opcodes. Again, that's not a badge of anything great, other than it's a realization that, oh, that's that's some work that we've done. All right, so having said that, where are some other places that would benefit from it? Maybe you could look and say, we got the jumps, null val, and that's for creating them. Oh, we've done a lot. A period. If you did a dot something, it has to load a first. If you could just say no, use an index of something. That could work. Same way with indexing. Same way with slicing. Slicing is more complicated. There's 3 options there. If we did all 3 permutations, that means there's 8 of them. Well, we'll think about it. But yeah, all right. So that, we're just going to stop. How about that? Yep, I'm going to stop. Thank you for joining us. Again, a lot of good progress. And I'm still mulling over how to increase our efficiency with our garbage collected values. Still thinking about it. That's fine. We'll worry about it later. Have a great night. Thank you for joining me. Bye.